Hi guys, Mr. B here, and today we're going to be looking at some SATs papers. So what I'm going to do is I'm running through the SATs paper, going through each question and showing you how to answer it. What I suggest you do is you download the paper from down there, print it off, and have a go at the paper yourself first. Then watch this video with your paper, run through, see if you've got the right answers. If you haven't, see where you made some mistakes and how you can correct those. Now, if any of the questions, if I have made any videos on that question that will help you out getting questions in future, if you've got more on them, I will put them up in the top corner. They'll come up so you can click on them and you can have a look if you want to. That means if you're on a question, you got it wrong or you find it a little bit harder, if you click up there, it will show you how to do them. Now, I haven't done videos on all the different types of questions you will get yet, so all the ones I have done will come up, and if I do more in future, I will add them in. Okay, let's get on with the paper. The paper we're going to be working through today is the Key Stage 2 2017 Maths paper, and it's paper 2, which is one of the reasoning papers. Question 1 is asking us to look at some graphs, and it says, William asked the children year 2 and 6 if they walk to school, and the graph shows the results, with the dark colour being walk to school and the lighter colour being don't walk to school. So the first one, it says altogether, how many children don't walk to school? So firstly, I'd be underlining my altogether, which means I know I'm adding up, and I need to know how many children don't walk to school. So I need to look up here. I can see don't walk to school is this colour, so I can see here I'm looking at this column and I'm looking at this column. So now where this meets, I can see that it doesn't have a number, so I have to work out what each one is. Now if we've got 100 and then 2 slots has taken us to 120, then I know that each line must be 10. So if this is 100, this must be 110. So I have 110 in year 2, but it says altogether. So let's look in year 6, we're at 80 here. We know our scale's 10 and it's 1 above 80, so that must be 90. Okay, so 110 plus 90, which I know is 200. Okay, that's how many don't walk together. I'll be using a rule with that one, going along these grid lines to make sure I'm matching it up. Now it asks me how many more, which is what I need to focus on. That's what it wants me to know. Year 6 children, then year 2 children walk to school. Remember this time it's saying walk to school. So I'm looking at the darker colour now. So I'll need to know how many more. So I can do one of two things. I can either say, well, this is my line here, so I know each line's 10 and I'm going to count up 10, 20, 30, 40, 50, and I know it's 50 more. Or I can work out that this is 120 and this is 70. So I could do 120, take away 70, and I would get my answer the same as 50, whichever way you find easier. Question 2 asks us to circle a number that is 10 times greater, so 10 times bigger. This is why it's important to learn all your different language. The 907. Okay, so 907, we're looking for a number 10 times bigger. I know if it's a whole number, if I am making it 10 times bigger, I am just putting a 0 on the end, which is technically, for all of you that know, my decimal point is here. And what am I doing is I'm moving every number up 1 value in place value. So we'll put my 9 into my thousands, my 0 into my hundreds, 7 into my tens, and then I put a 7 to fill the gap, so we know it's 9,070. Next one, we need to write the missing numbers in this multiplication grid. So it tells us the multiplication grid, and we've got the multiplication sign here. So if you haven't seen one, you can probably work out what they are. Because if you look, you can see all of these are in, these two numbers are in the 9 times table. So we need to work out what times 9 makes 63. Okay, if you know your times tables, you'll know it is 9 times 7. And if you know your times tables, you know that 9 times 6 is 54. So now we have 7 going down this column and 6 going down this column. So as you can see, 9 times 7 is 63, and then 9 going across times 6 is 54. So that's how we get our answers. So now we need to know 6 times what equals 48 and 7 times what equals 56. It will be the same number. So what you can do is think, well, I know my 6 tables better, and I know that 6 times 8 is 48. So I'll put my 8 there. Then to double check, you could see whether 7 times 8 is 56, which it is. And you would get 1 mark for getting each number of those correct. You got space here, you could do your working out if you weren't to show it on your times tables. Question 4 has a table and it shows us the height of 3 mountains. We have the height in meters, okay, with our heading here telling us of Mount Everest, Mount Kilimanjaro, and Ben Nevis. Now, our question is, how much higher is Mount Everest than the combined height of the 2 other mountains? So it's asking us 2 things. It's saying how much higher is Mount Everest, and it's saying the combined height. Okay, so we have 2 steps to work it out. Now, with reasoning tests, it will be maths that you know. If you had these sums in front of you, you would be able to do them. What the hard part about reasoning tests is working out what you need to answer. So you need to get used to reading these questions, find out what you have to do and doing it. So the first thing is we're going to find out the combined height of the other 2. So here are the other 2. So we need to do an addition. So we have 5, 8, 9, 5. I'm going to add the height of Ben Nevis up in Scotland. Now we're going to do some column addition. 5 plus 4 is 9. 9 plus 4 is 13. So put my 1 up here. 8 plus 3 is 11. Plus my 1 is 12. And 5 plus 1 is 6. Plus my other 1 is 7. So now I've got to find out how much higher Mount Everest is than these 2, okay, which we know is 7,239 meters together. So to find out how much higher, we can do a subtraction. So we can do 8,848, the height of Mount Everest, and take away the number we've just worked out, the combined height of Mount Kilimanjaro and Ben Nevis, and that will tell us the difference, which is tell us how much higher. Okay, so 8 take away 9, we can't do it, so we need to turn to 3, borrow 1 and put it there. So we have 18 take away 9, which will get us 9, sorry, and then we have 3 take away 3, which is 0, 8 take away 2, which is 6, and 8 take away 7, which is 1. So our answer is 1,609 meters. Okay, now that one is worth 2 marks. You would get 2 marks if you had the right answer, and you would get 1 mark if you started to go down the right path to get it, but say you made a mistake with some of your working out. So if you did these 2 sums and you forgot to carry 1 over or to borrow 1, you would get 1 mark for that. Question 5, we have a table and we have to fill in the blanks in these 3 squares. The top one's done, which shows what to do. So we have a number, and then this column we add 1,000 on. So first one's in this column, so we have 85 and we have to add 1,000 on. So we are doing this sum, which is easy because luckily we have a 0 and a 0 in the tens and the units columns, so we'd have 1,085. Again, if you want to do column addition, if you really struggle with maths, that will be fine. Now with this one, we need to be careful. We're not adding 1,000 on, we're taking 1,000 off, because this is a number and this is 1,000 more than it. So if you look, if we go backwards, 4,500, take away 1,000, it's 3,500. 1,085, take away 1,000 is 85. So we need to take 1,000 off from this one. So we've got 9,099. Take 1 off the thousands column, we'd have 8,099. Again, we have 15,250. We know this here is our thousands column. So we're going to take 1 off there, and we have 14,250. Question 6 asks us to write these numbers in order of size, starting with the smallest, okay, and make sure we don't get them the wrong way around. It's got smallest again here, really trying to give us a hand here. So what I would do is I find it easier to find the largest first, so I'm going to work this way. If you find the smallest first, that's fine. Okay, now I know when I'm looking at a number, I have to work my way down the place value, and the biggest number in the highest place value make it bigger. So these two numbers have zeros at the start in the units place. These have 1, so these two must be bigger. But because they both have a 1, I need to move on to my next, my tenths column, to see which one's bigger. So in my tenths column here, I have a 9, which is bigger than what I have in this tenths column, which is a 2. So I know this must be 1.9. It's the biggest number there. Let's cross that one out. Now I know this must be the next biggest number because it has a 1 at the start, and these both have zeros in the units column. 1.253. Remember, more numbers doesn't mean bigger. And now I have to look at my next column. Both have 0 on these two numbers. So I look at my tenths again. I have a 9 in this tenths column and a 3 in this tenths column. So 9's bigger. So this is the next biggest number. And then it's 3, so that must be our smallest number. So remember, with decimals, work your way down the place value, doesn't matter how many digits are there. Okay, if you have 4.36789, 100 will always be bigger because 100 is bigger than 4. So it's not about how many digits you have. Question 7, we have to write in the missing numbers, and this means we need to know how many months are in a year, how many hours in a day, and how many days are in a week. So we know that there are 12 months in a year. Okay, we have 12 months in a year, so what we have to do is find out how many 12s are in 60. So we do 60 divided by 12. If you know our 12 times table, that'll be easy. We have it as 5. If you don't, you might need to do some short division, but I would really suggest, as I do with all my papers in maths, learn your times tables. Okay, next one, we have to find out how many days are in 72 hours. We know that there are 24 hours in a day. Okay, so we need to do 72 divided by 24. You can do that as a sum, or you can just count in 24s. You can go 24, 48, 72. Okay, so you could do repeated addition of 24 plus 24 plus 24, and I would find that easier. That's the way I would do that, and I would know that it is 3 days. Okay, the reason I would do that rather than the division, oh sorry, I'm writing 24 there, I should write in 72. The reason I would do that instead of the division is because I know 24 is not far off 72, so I'm not going to have to add on that many times. If this number was 3,000, I'd be doing the division, because that's going to take me a lot less than keep adding on every time. Now I've got 84 days. I need to know how many days are in a week. Well, we know it's 7 days in a week. So we need to know how many 7s are in 84. So 84 divided by 7. As it's in our 7 times table, we will know that that is 12. This one is 2 marks. Okay, you would get 2 marks if you got all 3 correct. If you got 2 correct, you'd get 1 mark. If you only got 1 correct, you wouldn't get any marks at all. Okay, so that means we know how many months are in a year, how many days are in a week, and how many hours are in a day. Okay, it would also benefit you to know how many minutes an hour and seconds in minutes as well. Always numbers that we should know and will help us not just in our maths but going forward in life. Question 8 says, at the start of June there were 1,793 toy cars in the shop. During June, 8,728 more cars were delivered and 9,473 toy cars were sold. So how many toy cars were left in the shop in the end of June? Okay, so what we need to do is firstly work out how many cars they had, and then we'll take away how many were sold. So we know they started with 1,793 and then they had this many delivered. So to work out how many cars they had, we're going to have to add the 2 of those together. So we can do some column addition here. Oh, make sure that looks like a 2. So we have 8 plus 3, which takes us to 11. Oh, I need to be careful, man. Again, 2 there. My 2s look like 1s. Need to be careful with that. If your numbers don't look like they should do when you put them in the box, you will get the wrong mark, even though you've done all the hard work. So be really careful with that. Now we have 9 plus 2, which is 11, plus my extra 1 is 12. Then we have 7 plus 7, which is 14, plus 1 is 15. Then we have 1 plus 8, which is 9, plus another 1, which is 10. So that's how many toys they had altogether, 10,521. But they asked how many they had left at the end of June, and they sold this many. So what we need to do is some column subtraction. 10,521. I'm not going to put my top on. And they sold 9,473. Okay, this looks like it might be a tricky subtraction. We're going to have to borrow. So let's have a look. 1 take away 3, we can't do it. So we need to borrow 1 from there. And then have 11 take away 3, and that will be 8. Now we've got 1 take away 7, we can't do it, so we need to borrow 1 from here. That becomes 11, remember, not 12, because we've already borrowed 1 from there. 11 take away 7 is 4. So now 4 take away 4, which is 0. 0 take away 9, we can't do it, so that becomes 0, and we're going to borrow it and lend it there. 10 take away 9 is 1. So the answer would be 1,048. Okay, again, 2-mark question. You get 2 marks for the right answer. If you were doing this and maybe got mixed up when you were borrowing some in your subtraction, because we have to borrow 3 times there, you would get 1 mark. And we're looking at fractions, and we're looking at shapes that have different parts of them shaded in. So we have to tick the 2 shapes here that have 3/4 shaded. There's a number of different ways to do this. Okay, so we can see this first shape is 1, 2, 3, 4, 5, 6, 7, 8 equally sized pieces. That's what it's broken into. And there are 1, 2, 3, 4, 5, 6 shaded in. Sorry, my pen wasn't working there. So we have 6 eighths. Now I know when I change fractions, whatever I do at the bottom, I do at the top. So I need to see, can I make this into 3/4? Can I simplify that to 3/4? I know I can divide my bottom by 2 to get 4. 8 divided by 2 is 4. And if I do that to the bottom, it means I have to do the same to the top. I can see that 6 divided by 2 is 3. So we have 3/4. Another way you could do it is you could get your 8 and you want to find quarters. Okay. Now to find a quarter of something, we have to divide by 4. Same as if you have to find a half of something, which has a 2 as a denominator, we divide by 2. If you want to find a fifth of something, you divide by 5. A 6, you divide by 6, and you can see the pattern. So I can do 8 divided by 4, which will give me 2. So I know 2 is 1/4, but I need 3/4. So if I did 2 times 3, I would get 6. And 1, 2, 3, 4, 5, 6 are created. So either way I do it, I know that's right. Now this second shape, some of you looking at it might say that's a half, because you can see straight away we have 1, 2, 3, 4, 5, 6 different equal parts, and they're 3 shaded. So we have 3/6. And some of you might automatically see that that is a half. Okay, we can't divide this 6 by a number to get 4, so we know we can't turn it into quarters. Same with this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know it's broken into 9 equal parts, our denominator, and we have 1, 2, 3, 4, 5, 6, 7. So we have 7/9. Now I know I can't divide 9 by a whole number to get 4, to get quarters, so I can't turn this into quarters. So this can't be 3/4. Now let's look at this shape. Obviously it says tick 2 shapes, so we would assume this is right. Let's hope it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 equally sized shapes broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's broken into 12. Okay, now that we have 12, 6, we'll say how can we make this divide, what can we divide this by to make it into quarters. So I know that I can divide that by 4, and I will get quarters, 16 divided by 4. And if I do that to the bottom, I have to do the same to the top to make sure it's equivalent. And that would be 3 quarters, which is what we're looking for, which is great. Question 10, we have to round. So we have to round this number, 84,516. Firstly, the nearest 10. So I'm going to write my number, 84516. And I'm going to write the nearest 10. So I know this is my tens column. And when I'm rounding, I need to look to the number, one less in place value to it. And if it's a 5 or above, I round up. And if it's 0 to 4, I round down. So this is a 6, which means I round up. So it means all my other numbers stay the same. And my 1 rounds up to 2. And every other number after turns to a 0. So that would be 84,520 to the nearest 10. Nearest 100, again, do the same, but this time I'm looking at the hundreds column. So this is my hundreds column. I've got 5 in there. I look one less in place value, and I have a 1 in there, which means I'm rounding down. Now be careful, because what a lot of people do is they write the 84 and they say, I've got a 5, I'm rounding down, so that must be 4. But it's not actually, it stays as a 5. When we round down, we keep the number the same. Okay, the reason we're rounding down is because 50 is smaller than 51, so we have went down to the nearest 100. So that is our answer for the second one. And now we're in the swing of things. Next one should be easy. We're at the nearest 1,000. We look at our thousands column. Got a 4. Need to look 1 down in place value. We have a 5 there. 5 to 9, and we know we round up. So we change that 4 to a 5. Round up to nearest 5, and we change all the others to the equal ones. So you can see that is now 85,000. 2 marks, you get 2 marks for all 3, 1 mark if you got 2 of them, and no marks if you got any less than that. So 11, we have a rule for cooking chicken in here. We have to cook it for 20 minutes plus an extra 40 minutes for each kilogram, so however heavy it is. Okay, so the first question is, how many minutes will it take to cook a 3 kilogram chicken? Well, we know we've got 20 because everyone has 20 minutes plus an extra 40 kilograms for each 3 kilograms. So we could do 20 plus 40 plus 40 plus 40, or we could times the 40 by 3 first. So we know 40, 80, 120, and then just have 120 add on there. And we'd have 140. Now with this one you can do column addition, but with it being numbers that are 20 and 40, they are quite easy to add together. So if you can, to save time, count on your 20. Even if you count in tens, add another 40. We need to add 3 40s because it's 3 kilograms. Now it's saying what is the mass, which means weight, okay, of a chicken that takes 100 minutes to cook. Mass doesn't technically mean weight, okay, just thought I'd go back there before people start commenting on there, but it's what is commonly called weight, okay. So what is the mass of the chicken that takes 100 minutes to cook? Okay, so we need to take 100. We know every chicken takes 20 minutes, okay, so we'll take that off and we'll get 80. So now we know that the weighs 40 minutes for each kilogram it weighs. So I'm going to keep taking 40s off 80 until I get to 0. So I'll take off 40 and I would get down to 40. So that must mean 1 kilogram. And then 40 take away 40, straight away we know that is 0. So that was 2. So the chicken must have had a mass, of 2 kilograms. Question 12 asks us about the properties of 3D shapes. It asks us to take each shape that has the same number of faces as vertices. So first thing we have is a cube. Now, if you're unsure of the properties of 3D shapes, have a look up on them and find out what they are. I do have a video, which will probably be in the top corner there, if you need some more help with them. But a face is a flat surface on a 3D shape, so like this on the cube. And a vertices are where two or more sides hit, so like the corners, we might call them in real life. Okay, so let's start counting faces. 1, 2, 3, 4, 5, 6 faces for the cube there. 1, 2, 3, 4, 5, 6, 7, 8, more than 6 vertices, so it can't be that one. It's hard sometimes to count. You can see the dotted line means that they're behind, so just really try hard to count those faces. 1, 2, 3, 4, 5 if you count the bottom faces on the square base pyramid, and 1, 2, 3, 4, 5 different vertices. So we would give that one a tick. Triangular prism has 1, 2, 3, 4, 5 faces, and 1, 2, 3, 4, 5, and 6 vertices. So it can't be the triangular prism. And the triangular base pyramid has 1, 2, 3, 4 faces, and 1, 2, 3, 4 vertices, so it's that one as well. This one's 2 marks, okay? So if you only ticked one and nothing else, so you just ticked this one here and you didn't tick anything else, you get 1 mark. If you tick both of these and one of the other ones, you would get 1 mark. If you tick 2 of the other ones, you won't get any marks at all. Okay, but obviously if we know our properties of 3D shapes, we'll get it right anyway. Question 13. Ali and Jack buy some stickers. Ali buys 2 packs of stickers for £10. Sorry, 12 packs of stickers for £10.49, and Jack buys 12 single stickers for 99p each. How much more does Jack pay than Ali? So we need to know how much more Jack's going to pay. But to know that, we need to know how much each of them paid. We know Ali's paid £10.49, but we don't know how much Jack has paid. So he has 99. Okay, and he's bought 12 stickers. So I'm going to do 99 times 12. You could do a repeated addition, but I think this will be quicker. So this is the way I would do it. 2 times 9 is 18. 2 times 9 is 18, plus my 1 is 19. Remember, on long multiplication, we put a 0 in there because we're now timesing by 10, not 1. So 1 times 9 is 9. 1 times 9 is 9. Okay. So 8 plus 0 is 0. 9 plus 9, 18. 9 plus 1 is 10, plus 1 is 11. Okay. So I have now how much p he spent. 1,188p. So I need to convert that into pounds and pence. Okay. Which basically just means we need to put our decimal point here, because we know there are 100 pence in a penny. So we just go 1, 2, and it's £11.88. So now we have £10.49. And Ali spent £11.88. And we need to know how much more he pays, so we need to know the difference. So to find the difference, we need to take away. So we need to do 8 take away 9, we can't do. So we're going to borrow 1 from there, make that 7, not 18. 18 take away 9 is 9. 7 take away 4 is 3. Remember a decimal point, we line them up. And 1 take away 0 is 1, and 1 take away 1 is 0. So I've got there £1.39. Again, 2 marks you'd get for the right answer. If you showed that you were doing the right thing and then got mixed up with borrowing or lending or anything like that, you would get 1 mark. 14. Amina planted some seeds, and for every 3 seeds she planted, only 2 grew. So altogether, 12 seeds grew. And what we need to find out is how many seeds Amina planted. Now we know every time that she plants 3 seeds, only 2 grow. So I'm going to work out how many sets of 2 are in 12 to see how many sets of 3 she planted. So if I do 12 divided by 2, I'll find out that she planted 6 lots of 3 seeds. Okay, and 6 times 3 is 18. And that one might be a bit difficult to get your head around, but as we can see, every time she plants 3 seeds, 2 only grow. So if 12 seeds grown, she must have planted 6 lots of 3, because 12 divided by 2 is 6. Okay. Question 15. At the end of a film, the year is given in Roman numerals. And we can see at the bottom here, it has MMVI at the bottom. And we have to write the year MMVI in figures, which is quite an easy one. It starts to get complicated when we have smaller Roman numerals, okay, before bigger Roman numerals. But we don't. We have our biggest ones first, which is M, which equals 1,000. So we've got 1,000, 2,000, and then we have V, which is 5, and I, which is 1. So we have 2 1,000s. I'll put another one in there so we can see it exactly. A 5 and a 1. So 1,000, 2,000, 2005, 2006. Question 16 has us looking at question 16. Layla completes 1.5 somersaults in a dive, and our question asks us how many degrees does Layla turn through in her dive. So there are 2 ways to do this. We can either look at the question and see that it says 1.5 somersaults, so we know she spins round 1.5 times, or we can count down with our diagram to help us. Now for this, you need to know that there are 360 degrees in a full turn. So if you know that, you can easily work out what 1.5 turns are, 1.5 somersaults, because we know somersault goes all the way around. So the 1 somersault is going to be 360, and our half is going to be 180, because we know 180 is half of 360. Okay, so that is 1.5. So we'd add them together and we'd get 540 degrees. But there is another way to do it. You can have a look at your diagram. So we have her pointing up right first. Now we can see we've got it in quarter turns each time, and we know that's 90 degrees. Okay, so if you have a straight line there and you went down to be facing that way, we know that's a right angle, which is 90 degrees. So if we look, then she's got to her full upside down. It's another 90 degrees, which would equal 180. So as you can see, we can keep going down. So 180, add another 90 on, 270. Then we've got her facing back upright, so she's had her full turn, which is 360. And she's starting her half rotation, so we now have 450. And then she's back down, facing down for the completing the somersault and a half, which would give us 540. You can see we've added on 90 degrees each time, because in the little diagrams you can see she's spinning around that much. Question 17 can look quite daunting when you first look at it, and when you read the question it says the vertices of a quadrilateral have these coordinates. Remember, when we look at 3D shapes, vertices are where 2 sides meet. Okay, now it's got our coordinates, and it says one side of the quadrilateral has been drawn on the grid. Complete the quadrilateral. When we know it's quadrilateral, that's the first thing we can pick up, so we know it's got 4 sides. Obviously, it tells us to use a ruler as well. Now, these points here, these coordinates, tell us where the different points of the 4-sided shape will be. Now, the first 2 have been done for us. We can see we've got 1, 5, which is that one. Then we've got 5, 4, which is that one. Remember, it's always along the corridor and up the stairs. Okay, if you did forget that and you're thinking, oh, which way it is, I can't remember which order it's in, have a look at the two it's already got for you. Okay, you can see it's either 1, 5 or 5, 1 if you don't know which order they are. There's no 5, 1 in these coordinates, so it can't be those. Same with this one, it's either 5, 4 or 4, 5. 5, 4 is there, no 4, 5, so we know it must go along then up. So that will help us. If you're unsure with a question, always use what you've got to try and work out what you need to do if you're unsure. So our next one is 1 minus 3, so we know it's along then up, or because it's minus 3, down in this case. So we go along to 1 and then down to minus 3. So that's where our next point will be. So we've done that one. Then we've got minus 3, 4, so we know it's along first, so along to minus 3. So along our x-axis, and then up to 4, 1, 2, 3, 4. You can see it's in line with 4. Okay, for our next point. So as you can see there, we have our next 2 points, there and there, and we need to use a ruler to join them. Mine's not going to be using a ruler because I can't get one on here, but you'll see the general shape. Oh, I've missed that one. We'll do that one again. You can see the general shape, and we know it's quadrilateral. It's got 4 sides. And there we go, and that's what you will see on your finished answer. Question 18 tells us that a cat sleeps for 12 hours a day, which is 50% of its life being spent asleep, and a koala sleeps for 18 hours a day, and we have to find out what percentage of its life it's spent asleep. Now, it's telling us that this is 15 hours of its life asleep because we know there are 24 hours in a day. Okay, if you didn't know that, obviously we know 50% is half, so if we doubled it, 2 times 12, we would get 24. So we know there are 24 hours in a day. So out of those 24 hours, okay, 18 of them are spent asleep. So we have 18 over 24. Now, there are a number of ways to do this. I'm going to do this a couple of ways to see which way you would find easier. So what I'm going to do is I'm going to firstly, I know it's 18 out of 24. I'm going to simplify this fraction, see if I can get it to a fraction where I can turn that into a percentage, and you'll see what I mean. So I know 24, I know I can divide that by 6 because I know my 6 times table, and I would get 4. And if I divided 18 by 6, I would get 3. So I know that 18/24 is the same as 3/4, and because I know my equivalencies, if you're not sure with percentages and fractions, there are certain ones that you should know off by heart, and 3/4 is one of them, and that means it is 75%. So that is one way we could do it. Another way we could do it is using our percentage. We know 12 is 50%, so we could use that to find, and we know 24 is 100%, obviously. We could use that to work out by trial and error what the percentage would be. We know that 2.4 would be 10%. Because I've got 12, I know that 6 is going to be 25% because it is half of 50%. Okay. And you could go on and do 0.24 as 1, but when I look at those numbers there, I can see that I can, with 2 of those numbers, I can make 18. Okay, I can see that 50 and 25%, 12 plus 6 is 18. So 50% plus 25% would be 75%. It's quite a hard question there, so have a look at it if you struggled a little bit. There's 2 ways you can do it with your fraction or using your percentages. Question 19 tells us that Amina posts 3 large letters. I'm going to underline my information as I go here that I'm going to need. The postage for the cost for each letter is the same. Okay, and she pays with a £20 note and the change is £14.96. And I need to know what the cost is of posting 1 letter. So you can see this is going to be 2 steps because first I'm going to have to work out how much she spent and then divide that by 3 in order to find out how much each letter is on its own. So first let's find out how much she spent. There's 2 ways to do this. The way I would do it is I would see £14.96 and I need to find out how much she's paid, so I need to find the difference between these so I could do a subtraction, but what I'm going to do is I'm going to work my way up to 20 to find out. So I know it's going to be 4p to get to 15, because I know 96 add 4 will get us to the full pound, so that will be 15. And I know from 15 to 20 is £5. So I know that it must have cost her £5 and 4 pence. You could obviously as well do a subtraction with a decimal or not. Remember, when we're doing column addition and subtraction, as long as the decimal lines up, it's fine. But I could do it without it, because I could be doing it in pence. 2,000 pence take away 1,496 pence. I'm just going to put the decimals in there. So reason I wouldn't do it this way is because we have to borrow quite a bit all the way over, because we have all these zeros on the top. Okay, now I'm going to do this a slower way than I normally do, just to show you exactly what I'm doing. So I've got 0 take away 6, and I can't do it. I can't borrow 1 from here because there's none. Can't borrow 1 from here. I have to go all the way to this end. So I'm going to borrow 1. Remember, I can't take it all the way down. I have to take it down 1 at a time and pass it over to the next place value. Turn that into a 9, because I'm going to borrow another 1 and put it there. Do the same there, borrow another 1 and put it there. So now we can do our sum. Normally I would just put the 9s up straight away because I know what I'm doing, but that just shows exactly what we're doing. 10 take away 6 is 4. 9 take away 9 is 0. 9 take away 4 is 5. And 1 take away 1 is 0. As you can see, £5 4 pence got the same answer. Now, we know she spent £5 4 pence, but she didn't buy 1 letter, she bought 3. So we're going to divide that by 3 in order to find out how much she spent. Dividing a decimal, it's exactly the same as if we didn't have the decimal. We work down our short division the same. Or obviously you don't have to have the decimal in there, and you could be doing 504p. So 3, how many 3s in 5? There are 1 with 2 left over. How many 3s are in 20? Well, we know that 6 times 3 is 18. So we have 2 left over. Then we have how many 3s are in 4, which goes exactly, we know there are 8 times 3 is 24. So we have 168p, which we know is £1.68. As you can see, if I was just doing it with decimal in, the decimal point just goes exactly where it was in the sum. £1.68. You get 2 marks, 2 for getting the right answer. If you were doing the right working out but got mixed up maybe on your division, or when you're carrying ones over, then you would get the 1 mark. Question 20, we have to explain why Adam is correct, because he is saying that 0.25 is smaller than 2/5. Now be careful, it's not asking us is he correct, it says why is he correct. So it's always telling us that he's right, it's just explaining why. So if you just write in there yes he's correct, or you write yes because 0.25 is smaller than 2/5, you're not going to get any marks. You have to explain why you know that's smaller. Now there's lots of different ways to explain why it is. First way I would go is I know my equivalency. So I know that 1/5 is 0.2. So 2/5, oh, don't know what number I'm trying to write there. 2/5 is 0.4. And I can see that 0.25 is smaller than 0.4. And I would write that down and explain that. I know that 2/5 is 0.4, which is larger than 0.25. Another way you could do it is you could say something like 0.25 is 25%. And 2/5 is 40%. Again, equivalencies that you should know. So you can prove that way. Again, you'd explain in writing why that was true. Okay. Now that's because I know my equivalencies for 1/5 and 2/5 and 0.25. I know that. Okay, but there is a way to work it out if you didn't know. If you just know how to convert into different ones, then that is fine. Okay. So if you want to say 0.25, you convert that into a percentage, you know it's 25%. Okay, and even if you didn't know 25% is a quarter, you know it's 25 over 100. Okay, which equals a quarter. Again, we should know that 25% is the same as a quarter. Okay, and again, you could use that for your answer and say a quarter is smaller than 2/5. And then we've got 2/5. If we wanted to turn that into a fraction, we know we could do times that by 100, not by 100. We could times that by 20, to get 100. Because we know 10 times 5 is 50, so 20 must be 100. So we need to do the same to the top as we have to the bottom. So 20 times 2 is 40, because 10 times 20 is 10 times 2 is 20, so 20 must be 40. So we could do that one. We can see that we've got these two fractions here. 25 over 100 is smaller than there. But because we got 40 over 100, we know that's 40%. And we know that that is 0.4. Okay, technically 0.4, but we don't need our second O. So there's lots of different ways. I hope I haven't confused you with the different ways you can see it. It's whatever you know easier. So if you look at that and you think, I can turn 0.25 into a fraction easier than I can turn a fraction into a decimal, do it that way. If you know you can turn these two into percentages easier than you can convert any of the others, do it that way. Do it the way that you know is going to work best for you. Question 21 tells us on a map that 1 centimetre represents 20 kilometres. And the distance between two cities is 250 kilometres. So on the actual map, we need to work out what the distance is between the two cities. So we need to work out in centimetres how far those two cities would be away from each other on our map. So there's a number of different ways to do this. We could do 250 divided by 20, because we know it's 250 kilometers, and we know every 20 kilometers is 1 centimeter, so we could work that out. So we know that's 1 with 5 left over, and then that is 50. How many 20s in 50? There are 2 with 10 left over. Okay, if you know how to divide with decimals, you could work that out, but I need to find out. I would have 12 centimeters there. I know that remainder 10. I know that 10 is half of 20, so that'd be 12.5. Now with this one, you've got 2 marks. So if you did that and you did something like 12.1, you'd probably get 1 mark. But remember, this is a remainder. It's not our point. Okay. So if you know how to add an extra 0 on, carry a 1 over, okay, and keep going on, that is fine. Sorry. Or 10 over, that's fine. If you don't, you need to know that remainder 10 is half of 20, and we know half is 12.5. We don't write 12.5 centimeters, we write 12.5. Okay, you could also work it out by counting up in 20s. So we're going 20, then we'll add another 20, so we get to 40. Okay, and we'll keep going up, and eventually we would get to 240, and that will be our 12th one. So we know that we're 12. If we add another one, we know we get to 260. So it's 10 away, so we need to work out the difference, which again is a half. So it'll be 12.5. Another way you could do it is that you know that 20 kilometers is 1 centimeter. So you know that 100 kilometers, sorry about my M's there, 100 kilometers must be 5 centimeters. Okay, and we got 250. So we're going to have 5 plus 5, there's 100 kilometers plus 100 kilometers. And then if we need 50, we need to half 5, which is 2.5. Because we know that 50 kilometers is going to be 2.5 centimeters, because 50 is half of 100, 2.5 is half of 5, add them together, we'd get 12.5. Oh, 22 looks quite daunting. People can struggle with ratios, but it's really quite easy. So we've got 2 similar right angle triangles, so they're the same, but one's been made bigger. We need to write the ratio of side A to side B. Okay, so how much bigger B is than A. Okay, now looking at that, that might scare some people thinking, look, it's a diagonal, I can't work it out or anything like that. Now, there's a number of different ways that you can do it. Now, because of right angle triangle, we know that all the sides here, because the shapes are similar, have increased by the same amount. So rather than use the diagonal, I'm going to use this side here because it's straight and it's easy to count. So I can see I've got one block here and I've got 1, 2, 3, 4 blocks here. So that means my ratio is 1 to 4 and it is easy as that. A, so A goes on this side, B, A to B, so A and B on this side. Okay, again we could do it at the bottom as well. I've chose that side because I know that's one square big, so it's going to be easy to work out the ratio and I'm not going to have to make it smaller, because if we look here I've got 2 and then I've got 1, 2, 3, 4, 5, 6, 7, 8. So I could use that side, 2 to 8. See, if I half 2 and half 8, I get 1 to 4, because we have to make it smaller. That would be accepted though, just to let you know. And you have to be careful. If you got your numbers mixed up, 4 to 1 or 8 to 2, you wouldn't get the marks. Okay. This is how you work out ratios, and it's quite easy if you just study them for even just a little bit. Question 23 shows a circle with a quarter shaded here and a sixth shaded here. So we have a quarter and a sixth, and we need to find out what the fraction of the whole circle is not shaded. They do put them in bold reminders, but a lot of people do miss them, but it's not shaded. Now, problem with this is our fractions have different denominators. So we have, to find out how much is shaded, we have this sum, a quarter plus a sixth. Okay. Now, to add and subtract fractions, I've got a video on that if you need any help on it. We need to make the denominators the same. So I know that I need to find the lowest common denominator, which is going to be 12, because I know 12 is in the 6 and the 4 times table. So I'm going to look at this one first. I know that 4 times 3 is 12. So whatever I do at the bottom, I've times that by 3. I have to do at the top, times it by 3. 1 times 3 is 3. And then I'm going to do the same and get a denominator of 12 on the bottom here by doing 6 times 2. Whatever I do at the bottom, I'm going to do at the top. 1 times 2 is 2. So I've got that fraction, which is easy to add up. I've got 5 twelfths, 3 twelfths and 2 twelfths is 5 twelfths. So I know that 5 twelfths is shaded, and I want to find out what's not shaded. So I know that 12 twelfths is the whole. So 12 take away 5 is going to give me 7 twelfths. In the same way, you could also have a look, well, it's asking us not shaded, so I've got 1 quarter here, not shaded. And I have 2 sixths here, not shaded. Do the same, so we get 3 twelfths. Okay, because that's the same, but this one, we're going to have 12 on the bottom, but we're going to have 4. And that we know that 3 twelfths plus 4 twelfths is 7 twelfths. Okay, and that way what we've done is we've just looked at, we've got that one, then we've got the 2 sixths here, not shaded. Found out equivalent fractions that have the same denominators and then added them together. There is another way to do it. This way I wouldn't recommend. If you know that way, it'll be a lot easier for you. But you could have a look at your shape and think, right, what I'm going to do is I'm going to break this into equal parts and just count them. So we know a fraction has to have equal parts. So these lines will have to follow across. If that one does, so does this one. Now obviously I don't have a ruler on here. Okay. But a ruler would really help me out. Okay, I'll draw that line again because that is really bad. But we see this line here. Okay, now I can see there I don't have equal spots. I can see this is bigger than that, and that's bigger than that. So I'm going to have to half these again. And when I half those, okay, I'm going to do this line again as well, because I haven't got a ruler, but I really want you to see what I'm doing.
Okay, now I have equal parts. Okay, it will be more obvious to you if you use your ruler. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I'm going to have 12 on the bottom. And I can say 1, 2, 3, 4, 5 are shaded in. And I need to know how many are not shaded in. 1, 2, 3, 4, 5, 6, 7. 7/12 are not shaded in. Again, the same answer. Like I said, that way is quite difficult. If you know how to do this way, and if you don't, revise it, look at adding and subtracting fractions and find equivalent fractions, you will get your 2 marks. If you start down this track and get mixed up, or again start on this track and get mixed up, you might get 1 mark if you've got the working out, so make sure you put your working down out here. And that is the last question on the test.
Hope you found that video useful, guys, and if you have, please give it a thumbs up. Hit subscribe if you haven't already. You'll get notifications of any videos that I put up as and when I do. Please share it if you know anyone that will benefit from this and find it useful. And if you've got any questions or anything, comment or use the Twitter or the Facebook page. Till next time, see you later.